What's up everybody, welcome back. So we have most of our team deathmatch stuff working, and for now I want to take a look at some stuff that's still not in the project just because we didn't get around to it, or some stuff that may need fixing. So in this episode we're gonna take a look at zooming in while we're aiming, and we're also gonna add a button so we can switch our shoulders, and that also works in ADS. And we're also going to set up jumping because that's also still not in the project. So you might want to be able to jump and then dash around and stuff like that. So we're going to add that as well. If you like the project, please consider leaving a like. And if you want to get your hands on the project files, just join the YouTube channel or become a Patreon. And then you will get access to the project files in my Discord channel. So with all of that stuff out of the way, let's start today's video. So besides the zooming and jumping, there's also some stuff people in the Discord mentioned that still need some attention. So first of all, we have a bullet trace inside of our character. So if we go into the hero base and then server bullet trace, first of all, we do a trace to determine where we look at, and then we actually fire a trace from the weapon to this position. And we can actually fire backwards. So if we set this to for duration and then make it a different color, for example, then I can show what's happening. So if we go in game, so right now the trace will actually start behind the character. So over here you can see it's tracing from the camera. So for example, if I would be stuck half behind some collision, or there would be a character standing in between me and the camera, then I can actually fire backwards. So it kind of depends on how you have the collision set up for the camera component and things like that. But technically it can happen that you fire backwards. So we want to move this trace forward. Let me see. Oh really? So Unreal is freaking out again. Okay. So we want to move this trace forward, and how are we going to do that? Well, we're going to disconnect the start location, and we simply want to grab the forward vector from the camera. So we have that already here, and we can multiply. And then we can grab the actual length of our spring arm to make sure that we adjust it to that. So if we drag in the spring arm from the camera component, and from here get the target arm length, there we go, target arm length. And then I want to actually add a little bit to this, so we can also take into account the length of the player's arm and things like that. So if we move it forward another 50 units or so, we are really close to the actual location of the weapon. And then we can make sure that we simply plug this in over here, and it will convert it to a vector. And then we can grab this result from the multiplication and actually add it to the return value location over here. So if we add it and then plug these in, plug this one into the start position of the trace, and now the trace should actually start somewhere around the weapon. So if we go back in game, so right now if I fire, you can see it's actually firing from the weapon position and not from the camera position. So that should fix our collision issue with the fire weapon trace. And then there's also another thing with our fire animation montages. So if I would go back in game again, solo game, and then go start game. So for this I actually need the assault rifle, and if I'm firing my assault rifle, you will see my turn in place animations are blocked. So right now it doesn't play any turn in place animations, and we're gonna take care of that one as well. So the main reason for this, if we go inside of our animation blueprint and then look at the animation graph, our turn in place animations are playing over here in the default slot, and our fire animations are playing over here in the upper body slot. And both of those are set in the default group. And normally that wouldn't really be an issue, but our fire animations for the assault rifle, for example, are firing so fast that they kind of block our turn in place animation. So the easiest thing to do to fix this would be to actually add a new group. So over here, if we go inside of our animation manager, then we have the animation slot manager. So you can go to window and then open it from here. And you want to add a new group in here. So I'm going to call the new group something like attack. And then inside of this new group, you want to add a new slot. And I'm going to call this something like my upper body attack. So now we have a new group and a new slot in place. So we can go back to our animation graph. And for this upper body slot, we need to leave it in place as well, because that's playing our load animation. So we simply want to add a node for our new animation slot that we just created. And we simply want to add it after our additive hit reaction. So if we add a little bit of room over here, we can simply add a new slot. And then we need to select our new attack group with the upper body attack. So make sure this is over here. And then all we need to do is go inside of the actual montages. So if we go to the asset browser and look for our fire montages, then open them up. Then we need to change our slot and group over here. So we can simply select it and then attack upper body attack. So do that for all three of the montages. So I need to look at them again. So fire and then the filter for montage. So this was pistol, then we have a rifle. Make sure we change the slot and the group. And do the same thing for the shotgun. There we go. So now we should have our animation issue fixed as well. So if we save everything and try this again. Now we should actually be able to play turn in place animations while we are firing. So let me grab this weapon and some ammo. And then as you can see right now everything is working, and I can also still reload and turn in place, and all of that stuff seems to be good. So we have that one fixed as well. And now it's time to take a look at our ADS zooming. So to make sure we can zoom in while we are aiming, we need to go inside of our hero base character. And in here, we need to create a custom event first. So let's start with that. Let's create a new custom event. And I'm going to call this set spring arm length. So I'm going to make the spring arm shorter so the camera moves closer to the player. And I'm also going to change the field of view to make sure the camera zooms in. And both of those things we can do on the local player, because the local player is pretty much the only one that sees through the camera. There's only one thing we need to take into account, and that's the server doing the bullet trace from the camera. So we also need to make sure that the server knows the correct camera locations. But first we're going to tackle the spring arm and the zooming. So we're going to give an input to this event, and that's going to be isAds. So that's simply a boolean. And first of all, let's grab a branch in here, plug it in, and then we're going to use a timeline to make sure that the transition for the spring arm is smooth. So we're going to right click and add a timeline and call this something like a spring arm ADS. It doesn't really matter. So the true pin is going to go inside the play, and then the false pin is going in the reverse pin. Let's double click the timeline and set it up. So first of all, we need to add a track, and we want to add a float track. And we need to give it a name, so give it something like a spring arm lerp. And we need to set it up, so right click, add a key, and right click again, add another key. So the first key, select it and give it time 0, value 0. And then for the second one, I'm gonna put it at 0.15 seconds. So it's a really quick ADS animation. And the value is going to be 1. So that's pretty much the entire timeline. We do need to make sure that we grab the length of the timeline over here and adjust it to the last keyframe. So that's going to be 0.15 seconds. So as you can see, the gray area updates, and this is the entire timeline. So compile it, and we can go back to the event graph. And then over here we can use a lerp node to set up the length of our spring arm if we add two new variables. So let's create a new variable, and the first one is going to be our spring arm length. So that's a float, and let's duplicate it and call this spring arm length ADS. So for aim down sights, it's not really aiming down sights, but okay. So the defaults for the first one, you want to take a look at your spring arm and check what the current target arm length is set to. So 250 units. So I'm going to grab the first one and set that to 250. And then my length in ADS, I want it to be 100 units. So you can play around with these values, whatever you like. And then we can simply drag in both of them over here. And if we grab the lerp from the timeline and look for lerp, so that's a float lerp, and then we want to plug in the value from the timeline into the alpha, and then the spring arm length in A and the ADS length in B. So this will simply switch between these values. So if it's 1, it will be the spring arm length 1, so it will be 100. If it's 0, it will be 250, and if it's 0.5, for example, it will be precisely in between there. So this will make a smooth transition in between those values. And then we can simply grab our spring arm component over here and set the target arm length. Plug it into the update pin, and then plug in the return value from the lerp over here. So this will make our spring arm go shorter and longer depending on if we are ADSing. And then I also want to change the field of view. So for that one I'm also going to add two variables, and the first one is going to be simply field of view, so that's FOV. And then the second one is our FOV ADS. So by default your camera has a 90 field of view. So if you didn't change it, you want to set the normal one default to 90. And then for zooming, again, you can mess around with it, or you can choose to store these in your weapons data table and have different values for different weapons, for example. But for now, I'm just going to set the FOV ADS to 55 or 50, something like that. Again, whatever you prefer. And then we can simply grab another one of these lerp nodes, copy it, and then grab the FOV and the ADS FOV. So plug the normal one in the A pin, the ADS in the B pin, and grab the alpha again from our timeline. And then grab in the camera component, and from here we can set the field of view and simply plug in the return value from our lerp node. So this will make the camera move and zoom for the client. And as I mentioned, we do need to make sure that our server instance knows the correct length of the camera target arm, so we can actually still fire at the correct location. So we have our input action ADS event somewhere, so let's look for that. And it should be over here somewhere. So let's grab this to an empty place. So where is my new function? Oh, I'm actually right below it. Okay, so we have input action ADS, and this executes locally because this is an input event. And we want to make sure that all of this stuff executes on the local player as well. So we can simply call set spring arm length over here. Before we check if we have authority or not, that doesn't really matter in this case. And if we are pressing the button, we are in ADS, so we want to enable it. And if we are releasing the button, I'm copying the wrong node, so let's get this one. If we are releasing the button, we want to set it to false and then plug it back in as well. And now we already have a replicated event to set our isADS variable, so we can use that to make sure that the server actually knows the correct target arm length as well. So if we go to server set isADS, and let's move this over here as well, so everything is grouped. Then we can simply add a branch over here. plug in our isADS condition, and then if we grab our spring arm and set the target arm length like this, and then we need to grab the correct length. So for the upper one, that's the ADS length, and then we can copy and paste it over here, plug it into the false pin, and then plug in our normal length for the false branch. And that will make sure that everything updates over here as well. So because we set these values as defaults, we do not need to worry about replicating them, and we are not actually changing them in game. They are just these defaults and they don't change. So if you choose to store this on your weapons data table and you actually set it inside of the weapon functions over here, then you probably want to make sure that the server sets them and you have these set as replicated variables, so that way the server knows the correct value as well. So with this added, we should be able to zoom in. So if we go in game, solo game, and let's have a quick little test. So right now, if we ADS, you can see the camera is smoothing in and out, and if you actually smash the button, it doesn't really break anything. So that's working. Oh, really? Okay. And now we can also add a little input to make sure that we can switch the shoulder of the camera. So for the shoulder switching, we need a new input. So let's go to Edit, Project Settings, and add ourselves a new input over here. So if you're using 5.1, I will show you how you can set it up as well. First of all, let's take care of this one. So action mappings, let's add a new input and call it a switch shoulder. And for this, I'm going to use the X key, but choose whatever you want. So there we go. And now if you have a 5.1 project, let me grab a project in here quickly. So this is 5.1 and you have the enhanced inputs. So what you want to do is create a new action mapping. Right click, go to input and then create an action mapping, or an input action, sorry. And you just want to call this input action and then switch shoulder. And with this in place, you can go to the how this is called, the general mapping. I'm not sure what the name is, but just open this one. And over here, you can add the new mapping and then look for the new action that you created. So switch shoulder, and then over here, you can set up the new keybinds that you want for it. So if this is simply a button press, so for jumping or switching shoulders and things like that, that's really all you need to do. So if you go over here, you need to have it set up as a digital bool, and otherwise you will have access values for movement and looking and stuff like that. So for pressing a button, simply create an action input with a digital bool and then add it to the mapping context. That's the name I was looking for. So that's 5.1. And then if you have the new input set up, we can go back into the character. So we want to grab the input event for the new input that we just created. So that's switch shoulder. And then we also need a boolean to make this work. So we're going to add a new variable and call this isLeftShoulder. And then we also need two vectors. So let's create a new variable again and call this right shoulder location. So this is a vector. And then we also need one for the left shoulder location. So let's duplicate it. And that's our left shoulder location. So for the defaults over here, if we go to the spring arm, and over here we have the default location. So for me that's 40 and 110. So that's the right shoulder location. So let's compile it and we can set defaults 40 in 110. And then for the left shoulder you simply want to mirror it. So that's going to be -40 and then 110. And then the default for the is left shoulder should be false, so that's good to go. Now if we press the button over here, we want to set is left shoulder, so we're going to drag it in, and then we're going to get the current value and simply swap it around by adding a not bool and plug it in. So this will make sure it switches from false to true and back. So then we need to know if we are the server or not. So again, we can make changes to the spring arm. Just do it locally, that doesn't really matter, but we need to make sure the server knows the location to do the correct server bullet trace. So we're going to create a custom event and call this one server is left shoulder. And this needs to be replicated to run on server. And we need the actual boolean in here as well. So is left shoulder. Then we can grab a branch, plug it in over here. And all we need to do is set the spring arm relative location. So we're going to drag in the spring arm and then set relative location. Plug it in the true pin and also grab one for the false pin. Make sure you plug in the spring arm in both. And then the upper one is going to be our left shoulder location. And the lower one is the right shoulder location. So again, we set these variables as defaults, so we don't need to worry about the actual replication. They just hold the correct value. So if we are a client or a remote, we want to call our server is left shoulder and plug in the value from here, so from the actual boolean. And then we want to actually move it for the local player, so we can just do that over here in the input event if we connect both of these to a branch. And we're going to plug in our is left shoulder boolean again, so we can use a timeline to move our spring arm. So let's create a timeline. And this one could be our spring arm shoulder timeline, for example. So for the true pin, again, we're going to plug it in play. And for the false pin, we're going to plug it in reverse. Let's set up the timeline. So let's open it up. Again, we need to add a flow track. And I'm going to make this also 0.15 seconds, so they match up. And we need to give it a name. So let's call it spring arm shoulder. Sorry. And we're going to add two keys to it. So right click, add key, and grab the first key, make sure it's at 0, 0. And then for the second key, make sure the time is 0.15 and the value is 1. Then all we need to do is adjust the timeline length over here. So that's 0.15, so it matches the last keyframe. And then we have the timeline set up, so we can go back to the event graph. And simply grab a lerp node again, so drag off here and let's lerp. Plug it into the alpha pin and we can grab our, in this case we need a lerp for vectors, I'm sorry. So if we grab our right shoulder location, for example, and drag off here and then look for lerp, we can get a lerp node that actually lerps between two vectors. So plug in right and left shoulder, grab the alpha from the timeline, and we simply want to grab our spring arm and set the relative location. Plug this one in the update pin and grab the vector from the lerp node. So that should be good. Now it's complaining about some... Okay, so we need to update this node and then plug it back in. And that should work. So this should pretty much be our setup. And right now, if we go in game, we should be able to switch the side of our camera. So if I press X, you will see it's moving and it's also working in ADS. So that's pretty smooth as well. So at first I also wanted to actually mirror the animation using a node in the animation graph. And I did take a look at it. it was pretty nasty to set up, especially with our turning place animations, because they would look like they played reverse, and it would also reverse the root motion. So if I would turn left, the root motion would go right, and to make that work we need to create new animation montages and fix the root motion and stuff like that. So that was going to be a little bit too much, but at least we can now switch the side of the camera if we are facing a corner at a weird angle. Okay, so that's the camera setup as well. And now the last thing we can set up for this video would be the jumping. So again, we need a new input action. So let's go to our project settings again, open our inputs tab, and let's add a new action mapping. So this is our jump, and I'm going to add the spacebar and open our hero base character again. So we need to set up this new input event. So let's look for input action jump. That's the action event over here. So if we press the button, we want to use the jump event, and that's just a default event. And if we release it, we want to stop jumping. So that's also a default event. Simply plug those in and replication will be taken care of. So that's really all we need to do inside of our character. And we can go into our animation blueprint now and make sure it's actually working with the animations. So first of all, let's go to the event graph. And over here at the beginning, we want to store our Z velocity. So let's move this stuff a little bit to the side. So that's the aim rotation. We already have a node over here that gets the velocity, so we can drag off here and break the vector. And then we simply want to store the Z velocity, so drag off here, promote to variable and call this velocity Z. Make sure you connect it up over here. And we also want to drag off our character reference over here and get the character movement component. So if we go all the way down, character movement, so the actual component over here, and from the character movement component we can drag off and get is falling, so that way we know if we are falling or standing on the ground. So we can promote this to a variable as well, and that's going to be is falling, and make sure everything is connected back up. So that's for the event graph, and then we can go into the animation graph and set up the actual animations. So over here, we store our pose in this locomotion pose, and we're using it again over here. So the use cast pose node, we can simply delete it, and we're going to right click and we're going to create a new state machine. So add new state machine, and I'm going to call this something like jump states. And double click it to open it. So over here, first we're going to add a new state, and this is going to be locomotion. And if we open this up, we can simply use our cast pose again. So use cast pose, and then use the locomotion pose, plug it in over here. Go back to the state machine, and over here we're going to add a new state again. So add state, and we're going to call this state land. Now it created this transition, but we want to get rid of it because we only want to be able to transition from land to locomotion and not the other way. And then we're going to right click in an empty spot here and create a state alias and call the alias land alias. And plug this one into the land. So it looks like this. Now we can set up the conditions over here first. So if we want to use the, oh, I misspelled it again. Oh, freaking really doesn't matter. So over here, if we double click the condition, we only want to be able to make this transition if we are not falling. So we can simply drag in the boolean and look for not falling. Oh, that's a, so you want to look for a not bool and then plug that one in. I'm gonna get rid of the debug messages, they drive me crazy. Okay, so this is the transition over here. Then go back to the state machine, select the transition node, and you want to set up the blends. So for this one, we're going to lower the duration to 0.15 seconds and then set the blend to linear. And that should be good to go. Then for this transition, you want to drag a second time. So we have two transition conditions in here. We're going to select the first one, and that's simply going to be automatic rule based on sequence player. So just select this little tick box at the top over here. And we do want to change the blends again. So the duration over here is going to be 0.4 seconds. And then the mode is going to be cubic. And then we can set up the second condition. And that's actually speed condition. So we need to open this one up and we want to drag in our speed. So not the velocity z that we created earlier, but the simple speed variable we already had. And we want to know if this is greater than 0 and plug it into the condition as well. Go back to the states and make sure that we have our blends set up for this one as well. So this needs to be 0.2, but I'm going to set it to cubic and that should take care of it. So for the land alias, you want to select it and make sure we need to create other nodes first. We're going to get to that. So what we're going to do now is right click again in an empty spot, create another alias, and this is going to be our in-air alias. Oh, I really can't spell this word. There we go. So from here you want to drag off, create a new state, and this is going to be the jump state. From the jump state we're going to drag off again and create another state. And that's our isFalling loop. And then from the in-air alias, you also want to drag to the isFalling loop. So we all have this connected like a triangle. Now these alias nodes are new in Unreal Engine 5. And what this basically does is make it a little bit easier to keep the graphs clean. So if you select the alias node over here, you can select which nodes have access to the alias nodes. So for the in-air alias, you want to select the locomotion and the land node. So select locomotion and land. And what this basically does, you could kind of just copy it over here. And then the locomotion node can make these transitions directly to the jump and the isFalling loop if these conditions are true. And the land node can do the same thing if these conditions are true. So it just makes it a little bit easier to keep the graphs neat. It doesn't really do anything else than make a connection between the nodes you have selected. So for in-air alias have locomotion and land selected. Then we're going to set up the condition from in-air to jump. So let's select that one and let's double click it. So we need to make sure that we are not on the ground. So that means our isFalling boolean is true. And then we're going to add an end node in here and grab our z velocity. And if this one is greater than 100, so let's do greater than 100. So this basically means we are still moving upwards in the jumping sequence. So this is the condition. Then go back and set up the blends. So we're going to select the node again. And this one has a 0.15 blend. And we can keep the blend mode. That should be good. So for the transition from jump to isFalling, it's actually the automatic rule based on sequence player. So pretty much all this does is wait for the previous animation to finish and then it will blend. And for the blending, I'm going to set this to 0.3 and then make this cubic. And then we have only this transition node left. And we need to make sure that we set this to isFalling. So let's double click it and simply plug in our isFalling bool. Then go back over here and set up the blends. So let me double check. We're going to set this to blend 0.4 seconds. Oh. And then also set this to cubic. So this should take care of that stuff. Then all we need to do is go to our land alias and make sure that this one is accessible from jump and is falling. So we're going to select jump and is falling, and this will connect them kind of like I mentioned before. So this should be our jumping setup, and I pretty much just copied this from the third person example project. So it's not like I came up with all of this stuff myself. We do need to make sure that we have the correct animations in place. So for jumping, let's open it up. And in here, we're going to add the unarmed jump start. So unarmed. And we might need to turn that. No, we don't need to turn it. Really? Jump? Oh, I probably have the filter. Okay, so I still had the montage filter selected, and this is actually not a montage, but it's just an animation. So unarmed jump start. You want to drag this one in over here, plug it into the output pose. Then for the land alias, we also need to set it up. So let's go in here. And we actually going to use an additive animation for this. So first we're going to grab our cast pose again. So use cast pose locomotion. From here we're going to apply additive. And then for the additive animation, that's going to be the jump recovery additive. So again, unarmed jump recovery additive. Plug it in the additive pin. Plug this one in. And that should be good. And then all we have left is the falling loop. So if we go in there, we need to add our jump fall loop. Again, I'm grabbing the unarmed because we're blending the upper body animation, so that doesn't really matter. And now we have the entire jump state machine set up as well. So let's compile and save. And we need to go back into the animation graph and make sure we actually connect it up to the base pose from the layered blend per bone. So now this should work again. And if we go in game now, we should be able to jump with some animations. So let's have a little look. And that's actually working as well. And we can dash and jump, for example. So we have a little bit more movement freedom in game now. So I think that's everything we're gonna do today. Hope you enjoyed the video. If you did, please consider leaving a like, and I'll be back soon for more. So I have some more stuff planned, like crouching. We're gonna add simple foot IK for the mannequin, and we're also gonna add melee and probably grenades. So a few things that are coming. Hope you enjoyed. If you did, please consider leaving a like. I'll be back soon for more. Talk to you later, guys. Bye bye.